Okay, for this one, remember what you want to do is choose coordinate systems. Well, first of all, you don't need a free body diagram, right? Because it's 1 degree of freedom. You're given one single dot term, and you're also given a double dot term because it says that the theta dot is constant. So theta double dot is 0. So you don't need a free body diagram, you can calculate it. Now remember, you should choose a coordinate system that makes the acceleration as easy as possible. It looks like r theta, which you can do, and I will do that in the next video. But for this video, I'm going to do what I said, and that is I'm going to choose horizontal and vertical. So if I want to find the acceleration, I find the position. So I'm going to call this y, and that's position. And then if I take 2 derivatives of y with respect to time, I get the acceleration. So that's what I'm going to do. So since you're telling me the value of theta and you're asking me for y, what I'm looking for is an equation that relates theta and y. You do not want to use the hypotenuse. You don't want to use this triangle here because that involves r. So what you're going to do is you're going to use the horizontal dimension of 4 and the vertical. So that would be tangent of theta is equal to y divided by 4. So I'm looking for y, so I'm going to solve for y. Y equals 4 times the tangent of theta. Alright, so let's just take 2 derivatives. And I have to use a chain rule because this is theta, not t. So y dot is equal to 4, the derivative of the tangent, according to the hint, derivative of tangent secant squared. So this would be the secant squared theta, theta dot chain rule. Okay, let's take a second derivative. Okay, I'm going to treat this as one term times the second term. Right, 2 terms. So here what I have is y double dot is equal to 4. Derivative of the first term is 2 secant theta to the power of 2 minus 1 is 1 times the derivative of the secant, that is, according to the hint, secant tangent. So that would be a secant theta, tangent theta, times the chain rule, times the theta dot that I had from before, this one. Okay, plus the first term times the derivative of the second term. Boom. Okay. So now what you know is that the theta double dot is 0 because theta dot's a constant, and I'm left with this is y double dot equals 8 secant squared of theta times the tangent times theta dot squared. Theta dot is 3, so that'd be times 9. Okay, and some of you said you didn't have a secant on your calculator, so this would be 9 times 8 is 72. Tangent of theta. Secant is 1 over the cosine. Plug numbers in. The number is 30 for theta, so this is 30. 30. And my calculator gets 55.4. Okay, that's it. And I'll do another one, and this time I'll use polar coordinates.